All right, 5.1, solving systems of linear equations by graphing. So starting off, a system of linear equations is a set of two or more linear equations with the same variables. And by saying same variables, it also means that they need to be graphed on the same graph, right? They belong together. An example of one could be something like x plus y equals 7, or 2x minus 3y is negative 11, right? These together make the system. Individually, they are linear equations. Together, they are a system. Example 1, tell whether this ordered pair is a solution to the systems of equations. So let me first copy down this correctly. This should be negative 3, and then negative 4x plus 3y equals 5. I'm not really sure why it doesn't copy the symbols down on my iPad or not, but oh well. So if it is a solution to the system, it has to be a solution to each individual equation here. So starting off, I'm just going to plug into the top one, and then I'm going to plug into the bottom one, and I'm going to see is it a solution to each of them individually. So looking at the top one here, I'll make this one be blue. I'd have, this is my x, this is my y, 2 plus 1 equals negative 3. Oh, excuse me, this is a negative 2 and a negative 1. Negative 2 plus negative 1 is negative 3. That's a true statement. That is a true statement. Checking the bottom one here, I'd have negative 4 times negative 2 plus 3 times negative 1 equals 5. Well, negative 4 and negative 2 is 8, and then that would be minus 3, and that does equal 5. So yes, that would be a solution to the system. Alrighty, scrolling down. This should be a negative 1. That should be a positive 4. Then I have y equals negative 5x minus 4, and y equals 4x plus 8. Again, I just need to plug in and see if it works out. I'll plug into the top one first. I'll have 4 equals negative 5 times negative 1 minus 4. So 4 equals 5 minus 4, which is not true. We don't even have to check the other one. We know that the first one is no, so it doesn't really matter if it satisfies the second one. If either of these two is no, then it's no overall, right? For it to be a solution, it has to solve each equation individually. Now, you don't necessarily have to copy all this down, but this is generally how we're going to go about this if we want to solve them by graphing. So step 1, graph each equation in the same coordinate plane, right? We should be pretty good at graphing lines now. We estimate where do they intersect? Where does it look like they intersect on the graph? And then lastly is check the point from step 2 by substituting in for x and y to check, just like what we did up here. Now, I am only going to check it if it does not cross on the crosshairs of the graph, right? If I have to abbreviate like 1.5 or something like that, I'll check it. But if it's on the nice crosshair, I'm not going to check it. So let's graph one of these. This is y equals negative 4x plus 9, and y equals 3x plus 2. Now, whenever I go to graph this, now these are one of the times where you're going to want to graph relatively nicely. Right? You're going to need to do pretty decent at your graphing. I need to go all the way up to 9, so I need to probably be taller than that. I'll graph my top one in blue, so I go up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go right there. Slope is negative 4, so I go down 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. And I'll go ahead and do another 1, 2, 3, 4, and over 1. All right, there's my blue line. Now for my orange line, I have an intercept at 2. And my slope is 3, so I'm going to go up 3 and over 1. Oh, there's a spot. that point right there where they cross is my solution, and that would be at 1, 2, 3, 4, 5. So that's our solution. Scrolling down. Example 3. My point here would be -4, -2. And then I have -3x plus 4y equals 4. And then y equals -x minus 6. Solving this one, I'm going to get the top one and solve it for y because I want to put it in slope-intercept form. That would be 4y equals 3x plus 4. And then dividing by 4, I'd have y equals 3/4 x plus 1. Right. Now they're both in slope-intercept form, and it would be easier to graph. I'll draw a nice big graph for this one. The first equation, I'll make it blue because that's what colored already is. I have intercept at 1. My slope is 3/4, so I go up 3 and over 4. And I'll go down 3 and left 4 as well. My second one, I'll graph orange. 1, 2, 3, 4, 5, 6. My slope is -x, so I'm going to go up this way. And there we are. That would be at -4, -2. Oh, it asked me, is this an ordered pair? Well, I've just found it, so I hope it is. I did the problem wrong there. I didn't actually have to do all that. I just had to plug in. But I read the problem wrong, and we got the right answer, so yes, that is a solution. Example 4. This one we need to solve by graphing. Let me get this. This is y equals 1/3 x plus 6, and y equals -2/3 x plus 3. Graphing this one. The top one has an intercept of 6. 1, 2, 3, 4, 5, 6. My slope is 1/3, so I go up 1 and over 3, or I could go down 1 and left 3. My other line has an intercept of 3, and I'm going to go up 2 and left 3. Oh, there it is. So that's going to be at -3, 1, 2, 3, 4, 5, 5. There's my answer. All right. Again, if you're doing these on your own and you get one to where it crosses like maybe in the middle of a point or in the middle of a crosshair on your graph, you should probably go ahead and plug that back in when you're done just to make sure that you guesstimated correctly. All right, that's that.